The familiar rhythm of the calendar, the predictable succession of mornings, is not a law. It is merely a statistics-based convenience, shattered entirely at 51 minutes past 6 a.m. on June 19, 2026. The conceptual fault line of this entire investigation is defined by a singular, non-negotiable metric: 9 earthquakes, all strong enough to be felt, all condensed into a single 4-hour window before lunchtime, all occupying nearly the exact same patch of cold Pacific water off the eastern edge of Russia. It was not a series of tremors or subtle scientific curiosities. For anyone in the regional capital of Petropavlovsk-Kamchatsky, it was a systemic rejection of the very metaphor of stability. The ground simply refused to agree to stop moving. 3 of these events, a magnitude 6.6, a 6.0 less than a minute apart, and a 5.8 an hour later, were powerful enough to individually lead the global news cycle on almost any other coastline on Earth. They were shallow, and they were precise releases of energy. This cluster, which would be noise in most places, is a high-level signal, because this sequence did not happen in most places. It occurred on a subduction boundary, a machine that has historically produced some of the largest earthquakes humans have ever measured. This is the logic of hard limits. When a shallow earthquake, the result of 2 colossal slabs of rock, or tectonic plates, grinding together, occurs beneath the ocean this close to shore, it is not given the benefit of the doubt. The true scale of the risk, the profound systemic deficit of reaction time, is anchored by a single action. Within 15 minutes of the larger shocks, before most of the world had woken up, a tsunami bulletin went out for the Commander Islands region. There is a hierarchy to these things, and that response, evaluating whether the ocean is evaluated, watched, advised, or warned, defines the reality of the threat. On this morning, the response was measured at the lower end of that ladder. The ocean, in the end, stayed mostly still, but the speed of that notification was a direct acknowledgement of the structural limits of this specific geophysical system. Shallow earthquakes under the sea near a coast that has drowned before are watched immediately because the professionals know exactly what this particular fault is capable of. And they know that for a wave born this close to land, the time to react is measured in minutes, not hours. But the central systemic question remains, the one that no one watching could answer while the ground was shifting. Is a burst of 9 events the end of a sequence, or the very beginning of a larger structural collapse? To understand why this specific sequence of 9 earthquakes should cause deep systemic concern, one must dissect the physical engine operating 40 kilometers below the Kamchatka Peninsula. The surface of the Earth is not a unified shell. It is segmented into enormous tectonic plates moving at the speed of human fingernail growth. Under normal conditions, this slow drift remains invisible, allowing humanity to build its civilizations on the false assumption that bedrock equals absolute stability. At the plate boundaries, however, that assumption is invalidated by a violent, slow-motion convergence. Off the eastern coast of Kamchatka, the Pacific Plate, a massive slab of oceanic rock, is driving downward at a rate of 75 to 80 millimeters every year. It plunges into the hot interior of the planet along the Kuril-Kamchatka subduction zone, a boundary marked by a yawning gash in the seafloor known as a trench. If these plates glided past each other smoothly, the region would remain seismically quiet. Instead, the rough faces of the rock lock together under colossal pressure. While the planet's internal engine continues to push, the locked patch refuses to slip, warping and storing energy like a massive planetary spring wound tighter year after year. When this structural lock inevitably fails, the stored strain is released in seconds, causing the rock to lurch by multiple meters. This sudden displacement is what we record as an earthquake. Every single red dot that appeared on the monitoring screens on the morning of June 19th represents the physical slipping of this locked interface. Subduction zones are the only engines on Earth capable of generating megathrust events. the absolute largest earthquakes in recorded human history, reaching magnitudes up to 9.0. The size of the earthquake is determined entirely by simple geometry. The locked surface of a subduction zone is not a line, but an immense tilted plane the size of an entire country. When a small patch slips, it yields a moderate event. But when a country-sized section breaks free simultaneously, the energy released is catastrophic. This morning's swarm was concentrated precisely on this megathrust boundary. The critical question haunting this sequence is whether these 9 localized ruptures safely bled off the accumulated strain or simply redistributed it, loading adjacent locked patches closer to their critical failure thresholds. This deep tectonic machine also drives the region's intense volcanic activity. As the ocean plate sinks, it carries trapped water into the hot mantle, lowering the melting point of the surrounding material and generating magma. This lighter, molten rock rises to the surface, creating a long line of active, snow-covered volcanoes across the peninsula. These volcanoes are the visible, smoking exhaust of the same subduction engine that generated the morning's seismic swarm. On the vast timescale of this fault zone, which has operated continuously for millions of years, the entire history of human presence is a brief afternoon. The catastrophic 1952 earthquake is an event that occurred a mere heartbeat ago on the geological clock. Because the fault measures time in centuries while humans measure it in news cycles, we are perpetually vulnerable to mistaking a temporary period of quiet for permanent safety. For decades, the system remains silent, lulling the population, until it abruptly speaks in a burst of 9 earthquakes in 4 hours. This immediate risk is concentrated upon the regional capital, Petropavlovsk-Kamchatsky, a port city of 180,000 people. It is one of the most seismically exposed and geographically isolated cities of its size on the planet, with no road connecting it to the rest of the continent. In the event of a structural failure of the fault, there is no highway out. The stakes of this swarm are not abstract. They are directly linked to the physical depth of the ruptures. The morning's events occurred between 4 and 28 kilometers below the seabed, with several placed at 10 kilometers or less. This shallow placement is precisely what allows an earthquake to couple its energy directly into the ocean column, transforming a displacement of rock into a displaced mass of water. The core frustration of modern seismology is that after a century of observation and the deployment of global tracking networks, the system remains fundamentally incapable of determining if a cluster of earthquakes has reached its conclusion. When a fault shifts 9 times in 4 hours, the data arriving at monitoring centers provides perfect visual clarity but absolute zero predictive insight. Mechanically, these clustered events can be categorized into 3 distinct operational patterns, yet their real-time signatures are completely identical. The first and most statistically common pattern is a main shock followed by an aftershock sequence. In this scenario, a single dominant rupture occurs, and the subsequent smaller events represent the surrounding rock adjusting to a new structural configuration as energy bleeds off. While aftershocks can be highly destructive to weakened structures, this pattern offers a degree of reassurance. The largest release of energy is already in the past. If the magnitude 6.6 event was the main shock, the system is safely winding down. The second pattern is a true seismic swarm, which manifests as a flurry of similarly sized events without a single dominant rupture. These are often driven by fluid migrations, magma shifts, or slow motion creep along the fault. While highly unsettling, true swarms frequently exhaust their energy over days or weeks without triggering a catastrophic failure. They represent a fault fidgeting rather than structurally collapsing. The third pattern, however, is the catastrophic exception, foreshocks. In this scenario, the initial cluster consists of small fractures, indicating that the rock is beginning to give way in localized pieces immediately before the entire country-sized plain fails at once. The cruelest limitation of Earth science is that a foreshock carries no unique signature, no distinct wave frequency, and no warning signature on a seismograph. A magnitude 6.6 event that initiates a catastrophe looks exactly like a magnitude 6.6 event that ends one. The classification can only be determined after the fact. While the global monitoring networks provide data accurate to a tenth of a magnitude unit and locate hypocenters within a few hundred meters, they remain entirely blind to what occurs in the next hour. To evaluate this specific cluster, experts must rely on empirical statistical laws. The first is the rule of aftershock magnitude, which dictates that the largest aftershock shock is typically more than one full magnitude unit smaller than the parent main shock. On June 19th, the events following the 6.6 shock included a 6.0 and a 5.8, placing the sequence right at the upper mathematical boundary of a standard aftershock decay model. The second metric is timing. A normal aftershock rate decays predictably in proportion to elapsed time, thinning out as the hours pass, which match the observed behavior of this morning's cluster. However, the true anomaly is revealed by the Gutenberg-Richter relationship, which establishes that for every step up in magnitude, the global frequency of earthquakes drops by a factor of 10. Across the entire planet, only about 100 magnitude 6 or greater events occur in an entire year. To record 3 events near or above magnitude 5.8 within a single 4-hour window, confined to a small patch of seabed, represents an extraordinary concentration of energy. It is equivalent to packing a significant slice of global monthly baseline activity into a single morning. While the statistics gently favor the routine interpretation that this is merely a main shock settling down, probability is not prophecy. The identical statistical parameters were fully satisfied by the clusters that immediately preceded some of the greatest disasters in human history. The fundamental difference between an eclipse, which is governed by a small number of clean orbital bodies, and a megathrust of fault is the element of chaos. A fault is a highly irregular, high-pressure boundary where the ultimate outcome hinges on the microscopic strength of invisible points of contact deep within the Earth. We are standing next to a bent planetary branch, listening to it creak, unable to tell whether each snap is relieving stress safely or accelerating a total structural failure. To truly comprehend the magnitude of the threat, the human mind must confront its own inability to understand exponential physical scales. The magnitude scale used to measure earthquakes is not linear. It is an energy logarithmic function where each whole unit represents an approximate 32 times increase in seismic energy release. A magnitude 7 releases 32 times more energy than a magnitude 6. A magnitude 8 releases 1,000 times more, and a magnitude 9 releases roughly 30,000 times the energy of a magnitude 6 event. When comparing this morning's magnitude 6.6 shock to the historical earthquake that struck this exact same Kamchatka fault on November 4, 1952, we are not looking at a slightly larger event on a continuous slope. We are comparing a firecracker to a continent-shaking detonation. If this morning's largest quake is visualized as a single coin in your palm, the energy of the 1952 magnitude 9.0 catastrophe requires a mountain of 30,000 coins stacked against it. Yet both events are products of the exact same machine, driven by the same subduction mechanics. The only variable is how much of the locked megathrust surface breaks free at once. In 1952, the rupture was not a localized point, but a cascading failure that ripped along hundreds of kilometers of the plate boundary faster than the speed of a jet airliner. As the continental plate violently shoved upward over the subducting oceanic slab, it displaced the entire vertical column of water resting above the seabed. This is the precise mechanical origin of a tsunami. Unlike wind-driven surface waves, a tsunami is a displacement of the entire ocean depth, propagating across the open sea at speeds up to 700 kilometers per hour. While virtually undetectable in deep water, These waves slow down and stack vertically as they enter shallow coastal zones, transforming into massive walls of water. This physical reality explains why a tsunami bulletin was initiated within 15 minutes of this morning's shallow ruptures. The specialists understand that a shallow subsea failure does not just shake the Earth. It physically flings the ocean at the shoreline. The 1952 wave scoured the Kamchatka coast and the nearby Kuril Islands, but its energy was not contained locally. It traveled thousands of kilometers across the open Pacific Ocean with near-perfect efficiency, striking the Hawaiian Islands hours later. It surged into bays, smashed maritime infrastructure, and flooded low-lying communities on the far side of the planet. The Pacific Ocean is not an isolating barrier, it is a direct mechanical conductor of energy. A massive kinetic displacement on one edge of this closed system transmits a physical impact to every other shoreline along its perimeter. This is why the 9 earthquakes recorded this morning cannot be viewed as a localized anomaly on a remote map. The unreadable signal of this morning's swarm is being interpreted by monitoring agencies through the lens of that explicit 1952 data. The quiet horror of a tsunami is that its arrival is frequently preceded by the sea drawing back from the shore, exposing the seafloor and stranding marine life. This is not the wave receding, but the physical trough of the wave arriving first. Historically, this strange spectacle has drawn curious individuals out onto the dry seabed in the final minutes before the water returns as an unsurvivable vertical wall. A tsunami can arrive under clear skies on a calm day, striking a coastline that felt absolutely zero shaking from the source earthquake. By the time the ocean demonstrates visible anomalies, the window for human survival has narrowed to almost zero, necessitating automated warning systems that can outrun the physical wave across the basin. Because bays and harbors act as geographic funnels, they concentrate and amplify even modest deep-water energy into catastrophic coastal surges. Distance provides nothing more than a time delay. The structural reality remains unchanged. The fault that generated the trans-oceanic wave of 1952 is the exact same fault that twitched 9 times this morning, meaning the small numbers and the monstrous numbers are tightly bound within the same geological architecture. The temptation to dismiss the 1952 disaster as an isolated historic event relies on a comforting but deeply flawed piece of mathematical reasoning. Human intuition frequently attempts to spread the probability of catastrophic failures across centuries, assuming that once a system has suffered a massive release of energy, it must remain dormant for generations. This assumption is completely invalidated by the contemporary record. Just last year, in 2025, the Kamchatka megathrust suffered a major structural failure, generating a magnitude 8.8 earthquake. On a human scale, the distinction between an 8.8 and a 9.0 is negligible. It was a massive, planet-ranging event that ruptured hundreds of kilometers of the plate boundary and fundamentally redrew the stress maps for the entire region. This recent history introduces a fourth critical reading to this morning's sequence of 9 earthquakes. These events might not be foreshocks, a localized swarm, or an independent main shock sequence. Instead, they may be late aftershocks of the 2025 magnitude 8.8 event. The aftershock sequences of truly massive megathrust failures do not terminate in weeks. They persist for years and sometimes decades. A magnitude 8.8 deforms so much crust and alters local pressures so thoroughly that the entire geological system must continuously crack, shift, and settle to establish a new equilibrium. Because we are barely a year past that 2025 rupture, the physics of aftershock decay dictate that the fault should still be highly active, making this morning's cluster look like a predictable, late-stage reverberation of last year's monster. While an aftershock forecast can calculate precise mathematical probabilities for this settling process to help emergency managers allocate resources, it possesses an inherent, unmeasurable blind spot. The forecast can describe a stable universe where the swarm is fading, but it goes completely silent on the extraordinary case where the assumption is wrong. It cannot tell you if what you are recording as a late aftershock is simultaneously acting as a foreshock for a new adjacent rupture. This is the core mechanism of stress transfer, which defines the most complex puzzle in modern geophysical analysis. A megathrust fault plane is not a uniform sheet of glass. It is a highly irregular patchwork of varying frictions and stress concentrations. When one patch fails, the load it was carrying does not vanish. It is instantly redistributed onto the neighboring sections of rock. Like a row of laborers holding back a crushing weight, when one individual collapses, the surrounding workers must instantly absorb the transferred load, pushing them closer to their own structural breaking points. The 2025 earthquake relieved stress on certain patches while loading others to near-critical capacity. And this morning's swarm is unfolding directly inside that highly unstable, redrawn stress field. This reality reveals why the calm explanation and the ominous explanation are inextricably tangled. The 9 earthquakes may indeed be aftershocks of the 2025 event. But those aftershocks are the literal sound of stress migrating along the fault, like a crack propagating through a pane of glass. This brings us back to the stark lesson of March 9, 2011, off the coast of Japan, where a major magnitude 7.3 earthquake was analyzed by the world's best instruments and classified as a standard, self-contained sequence. 2 days later, that exact same patch of subduction zone produced the magnitude 9.1 disaster, revealing that the 7.3 event had been a foreshock all along. The data did not fail. The limitation lies in the fact that the difference between a minor settlement and a catastrophic precursor does not exist in the present data. It only exists in the future. Modern technology has achieved extraordinary milestones, such as seismic early warning systems that can detect harmless, fast-moving primary waves and send digital alerts to cities seconds before the destructive secondary waves arrive. This technology can stop surgeries, open elevator doors, and cut power grids. But it is an automated head start, not a prediction. It tells us an earthquake has started, but it cannot tell us that an earthquake is coming tomorrow. We can map the history of the rock in exquisite detail, but we cannot read its mind. This investigation into the 9 earthquakes off the Kamchatka coast leaves us at the absolute boundaries of what can be scientifically known. The machine under the coast is active, fully loaded, and working on a timescale that renders human history a brief distraction. On the morning of June 19th, the unreadable signal of those 9 red dots served as a stark reminder of our precise position. We are looking at a system with perfect clarity, yet we are entirely blind to its meaning. Standing next to a planetary engine that refuses to reveal its next move until the ground has already made its decision.